Okay, started. Voice started. Is it? Camera is
Hey, are you going to do the projector from there or from my machine?
from your machine. From the same machine.
So, Telugu.
Best delays. The screen is. Closed or paused. Screen
Yeah.
only your camera is seen. Your presentation is not seen. இது உங்க presentation இது வந்து camera இது உங்க presentation stop ஆயிடுச்சுன்னு நினைக்கிறேன் சரி you caffeine இருக்கா you will join automatically when the session is resumed either one of them only G-Talk நான் click தான் பண்றேன் too many clicks connecting
Okay, good. Hi folks, are we ready? Shall we start? Yeah? Okay. Welcome to another round of Geek Night. Okay, so my name is Vijay. I am a developer at ThoughtWorks. I do a lot of hobby development as well. And one of the things that came to my attention was a language called Elixir. So tonight I'm going to talk about Elixir. How many of you have heard of Elixir? And those of you who are sitting there, maybe you can come up so that you can see the screen better. How many of you have heard of Elixir? Or let me step back a little bit. How many of you have heard of Ruby on Rails? Awesome. Okay. So all of you, I'm assuming you've not only heard of ROR, but you've also at least dabbled in it, maybe as a hobby or something, or maybe you're even working in an ROR environment. Are you? Yeah. Okay. How many of you are hands-on developers, or anybody who is hands-on in the sense of coding hands-on? Okay, cool. So most of the talk today, actually the talk is about Elixir and about Phoenix. Elixir is the language and Phoenix is the web framework. So depending on your interest levels and all, you might and of course the time to use it. Yeah. I should keep it here then. Because I think everybody can hear me at least physically there, right?
Is it better or
better? Okay, thanks. Okay, so the thing is that what I had planned was depending on what your interest level of Elixir was and what your prior exposure to Elixir also was, I might do a little bit of Elixir and then jump on to Phoenix itself. Or if you've only heard of Elixir and you've not really done Elixir till now, then I wanted to kind of kindle your inquisitiveness, your interest to learn the language. So I have kind of the same deck prepared for both. And if we don't have enough time, we can probably do another continuation session next week night also about it. And that's just a little background of why some of the things are very basic, some of them are a little bit more advanced. Okay, so please bear with it. So can those of you who've heard of Elixir, can you say what caught your attention? Why Elixir? Anybody? Okay. Okay. Anyway, let me go forward. So concurrency is the biggest. Let me step back a little bit actually. Why do you do ROR? What is the benefit that you've seen, or what brought you into the Ruby world, and why you're doing say Rails or Sinatra or Papino or something? Why would a technologist choose ROR as a language or a stack to go and develop something? Exactly, right? So ROR, especially the framework, and of course the language because of the framework, is very well known because of the rapid application development capability that it gives you. And the main reason for that is the generators, right? And the DSL-like language, what you actually code, right? Of course, if you want to delve into really deep parts of Rails and active record and all the after hooks and before hooks and save hooks and all of that, that's also there. But you don't necessarily need to do that for any normal lightweight application, right? That's the reason people go to ROR in the first place. That you can go and very quickly develop proof of concepts or prototypes, showcase it to possible clients or whatever, or your managers, and then go forward with the ideation aspect of it. Of course, what that brings about is when you take that same thing, um, one of the things that I'll also disclose, is all of us, at least those who've been developers in any part of our life, we have showcased something which is very, very happy to our client or manager. They might approve it. Then they'll turn back and say, okay, build on top of that happiness itself. How many of you have experienced that? Right? That's like so true. You go tell them, no, it's a spike. I've done this shortcut, I've hardcoded this somewhere. It won't work in whatever you're thinking. They conveniently seem to forget or not hear that at all. Right? So one of the main things there is, and now we are starting to feel the pain, is that Ruby as a language does not do thread safe. It's not thread safe at all, right? We are finding ways and means, and of course we are creating tools to bypass that limitation. If you want to do multi-process, programming, threaded programming, you can't do that in Ruby. So you plop in something called DRB or background RB. Those are all gems for those who don't know. You plop those in, or you shunt it off to a Redis queue, and then from the queue you have another process which reads back and then does the process in a different thread. Right? That's the reason for all of that is because Ruby as a language does not have native threads at all. But you don't want to lose the power of the flow, the DSL like wording and programming style that Ruby gives you, right? One of the things that I've been a very very passionate Ruby on Rails developer for I think 8 or 9 years now, and I've contributed a lot of stuff. But all of these limitations caused me to be more and more frustrated with the language itself and the heavyweight, the way the Rails framework went on. So that is one of the reasons why I came into this Elixir thing itself. Right? So as we said, concurrency is the biggest benefit that you get, and of course it's thread safe by default. everything that you do, anything and everything that you do at a function level in Elixir is functional by default, and thus only within that function you're doing stuff. Outside it's always immutable. Right? The language construct itself is like grammar itself is like that. And because of this nature, at the language level, garbage collection is superb. One of the things I failed to mention, how many of you heard of Erlang? Do you know what the relationship between Elixir and Erlang is? Or even let me step back a little bit, sorry. Do you know when Erlang was created in the first place? Yeah. So Erlang was actually the full form of Erlang, or why it's called Erlang is it's Ericsson language. It was developed in Ericsson's laboratory. What they wanted to do in the 80s was they were the biggest, across the world. They were the biggest network providers for telephony switches. So in those days, we didn't have internet or anything, but telephony and fax messages, all those were the biggest way to communicate across long distances, right? Obviously, we were radio waves and all that, ham radio. But this is the most dependable way of mode of communication, right? So whenever there's a what's the thing called? Whenever there's a new version to be released, all of you have at some point of time need to release patches, need to release new versions of your software, right? So you, in some cases, you jump through hoops to do what is called blue-green deployment. You might need to do zero-time deployment, zero downtime deployment, all of that, right? So what these guys at Ericsson Labs came up with was a whole new paradigm, a language, and thus also a virtual machine, the Erlang VM, which can do something called hot code replacement. So while one version of code is running, you can deploy a new version of the same code. The registry will automatically, the language and the registry there will automatically reduce the memory clusters of the old version and send all the new requests to the new version. Okay, we'll come into that a little bit later, but that is one of the key reasons for using Erlang the VM. But at the same time, the language itself was actually very hard. How many of you have heard of Lisp or tried out Lisp? What is the biggest failure on Lisp? Or not failure, but the hardship of learning Lisp? The parenthesis, readability, right? So there are so many left and right parentheses, the square brackets, curly brackets, all of those have meanings in Lisp, and it's very hard to, as a programmer, to understand somebody else's code in that language, unless you have written it, and hopefully you remember all of that stuff, right? That's the biggest failing of that language. So the Erlang people they came from the Prolog background, so it was very adept and very fast at garbage collection, functional, and all of that stuff. But the language per se was very intricate. Okay, that's probably a good word to say. So all that background from Erlang, but they had the code, the VM was awesome. Like how many of you actually in India, maybe we have experienced it a lot more, but that's not because of this thing. But in more developed countries, right? If your telephone connection while you're talking, if it goes off, if the call gets cut, it's a huge deal, right? Even now, or maybe in current times in India, maybe we don't experience that so often. But like when I was a kid, it was very common. I'll be on the calls, halfway through the call go off, I'll have to redial the call again, right? But that is not something that is acceptable from the network operator's perspective. They want to do what is called 4 nines in Amazon lingo. It's called 99.9999% uptime. 4 nines, that's what that's called. So what they wanted to do was they wanted to have this, even while new versions of software are being deployed, the transition should be so smooth that there should be no downtime at all, right? That's the advantage of the Erlang VM. And coming back to Elixir, Elixir is actually a language which compiles into Bean code, which runs on the Erlang VM. Okay. So if you what is the mantra, I guess, or fallacy in some words of Java? So the marketing thing, the first thing that it did was write once, run anywhere for Java, right? Because it converts your Java code, compiles it into bytecode, and the bytecode is uniform across all architectures. The same bytecode can be deployed, and the interpreter or the compiler, JIT compiler on that architecture knows how to take the same bytecode and run it for that architecture. That's why the JRE installer is different for each Windows OS or Linux OS or BSD or OS X and all that. But the bytecode you generate can be done anywhere, can be run anywhere, right? Similarly is the case with Erlang VM, right? And Elixir capitalizes on that. It capitalizes on all the plus points that the Erlang VM gives you and gives you the facade of the language, which is much easier for today's programmers to do. And these are the main points here you see. Concurrency, thread safe, thread monitoring. So this the last bit I'll come. It is something that the language provides, but it's also a construct. It's not a grammar of the language. It is something that is in the standard lib of the language, but not the grammar. Okay. So anybody know what that difference is? Standard lib versus grammar. Okay. So grammar is a set of rules by which govern the syntax of a language. So even Java. Sorry. Oh, sorry. Yeah, sorry. So grammar is something like how many of you have done C programming? Header files. You've done header files, right? So it's something like that. Very, very close to header files is something called the grammar files. Or if you've done ASP compilation in Java or yeah, Java probably. Anybody done that? Abstract syntax, code generation. Okay. So these are all things that we used to do in the 90s and 2000s. That shows my age, sorry. Okay, so grammar is something that defines your syntax, and any say even when you, for example, when the OpenJDK project was started, and they had to the compiler that they produced or the interpreter they produced has to be compatible with the same bytecode semantics that the Sun's JDK does, right? So that comparison is controlled by the grammar. So in effect, they have to conform to that grammar, right? But the supervisor context is it's a construct on top of the grammar. It's still a language feature because it is in the standard library, but it's not at the grammar level. Okay, that's the difference there. Anyway, we'll come to some examples of those also. So don't worry too much on those things. Now, I think we covered these things earlier, right? Ruby's productivity is basically the DSL, dependency management. How many of you have done dependency management in Ruby or in other languages? What are the languages and what is the dependency manager? With? Yeah. So in Java, have you done anything like that? Maven, exactly. So Ant ID or Maven is the dependency management tool in Java and .NET. Anybody done .NET? No. Sorry. Yeah, Groovy also. But in .NET it's called NuGet packages. So there is one more participation. Okay, it's not going to be just a talk. I'm going to keep asking questions. Okay. Anyway, so sorry. Do you want new thing? Oh, sorry. Okay, so Ruby's this thing, right? Dependency management. We have something called, what is it called? Sorry. Oh, bundles. Gems. Yes. So gems. RPM is actually for the one flavor of Linux. Okay, so that's not the thing. But yeah, gems are what are the dependency management things that get dependency managed. And then of course Ruby's productivity also is through the meta programming that we can do. And finally, the biggest advantage coming from pre-Ruby, right? How many of you have done say Perl or C or any of the other older languages? You've done C. So how would you debug some program? Exactly. So you have to compile your code. You have to before that you put some breakpoints, and then you have to connect your debugger GDB into that, and then you need to know how the GDB works, right? Like all the commands in that to run, to step out, step in, all of those things. Nowadays everybody uses IntelliJ or Eclipse and fills down into with the GUI. But in the olden days it was very hard. So one of the biggest advantages of language like Ruby, in my mind at least, is the REPL, the interactive shell. You can open up a shell in the context of your application and then go and load up classes, load up files. You can invoke methods, create instances, and see how they each step it takes, right? So you can reproduce how your typical web request scenario is going to look like and go and debug it like that. You need not even debug it. You can even start writing code by doing it from the REPL, from the shell, interactive shell, right? So that, in my mind, actually was my biggest plus factor of coming from a Java world or .NET world into Ruby, so that I could do this wonderful non-IDE based debugging. Okay, and I also did a lot of Perl in the old days. So for me, an interpreted language was not new. But having a REPL was relatively very like a kid in a candy store. That's how I felt 10 years ago. Anyway, now these same concepts are exactly there, plus more things are there in the Elixir world also, right? You can write code in like a DSL. There is a dependency manager. There is meta programming. There is a REPL out there. Now what we'll do is let's go out of like the background information mode and go into the language itself. Okay. So there are actually is it learning? Sorry. Okay, so there are similar to other languages. There are some simple data types that are quote unquote standard in Elixir also. So the first one, of course, is integer, and then there's float, there's boolean. There's something called atom, and what an atom is very similar to a symbol in the Ruby world. Okay, but if you've never done, how many of you have never done Ruby here? Okay, so for those of you who don't know, think of it like a constant variable. It's a variable that's automatically defined, and the name of that is what we call as an atom, right? Except that a variable in other languages has a value that's separate from the variable, and in this case, the variable is its own value. An atom can be thought of as a variable with the same value as the name. Okay, there's no other. Exactly, right? So in the Ruby world also the same thing holds true for symbols. I think yes. So there are many things that came from Prolog into Erlang and then from Erlang into this thing. The biggest advantage that Elixir as a language has at this point in time is, even though it's like 2+ years old as a language, it can still use the full power of Erlang because you can load Erlang modules and call out to them. So Erlang standard lib classes are available in Elixir itself. Erlang, any third-party libraries that anybody writes for Erlang or has written for Erlang, you can call out in yours as long as it's there in your path to be loaded, load path, and then you can use it up. So that way, the full power of the Erlang and OTP applications are there in Elixir by default. Right? Exactly. Atom is from there. And then you have string and you have list and tuple. Everybody know what tuple is, right? Okay. Any questions till now? Or have I bored you enough? No. No answer even for that. Okay. Shall I continue? Okay. Is it kind of interesting? It's interesting for me. But of course, the best part for this thing is to take all this and show it to you in action, right? So what we'll do is we'll just jump from the PPT thing into command line, and I'll open up interactive shell and we'll type out those strings and see what happens. Yeah. Okay. So let me type out. Okay. So just type in 1. Okay. So we'll come to that thing a little later. Anyway, so I can also type in any such a string, and I'll type an array or list, and this is how you define a tuple, like so on like that, right? This is exactly what you saw here. Now, this one, the next thing about the basics of the language, after like when you learn a language, at least to me, my mind went from basic data types to some more if-else conditions and other concepts like that, and then to go and see how I can define a method, and then to go and see how I can define a class, right? So that's kind of how I'm taking this also. So if you want me to jump, please raise your hand or shout out. So the next thing I wanted to look at was, how do I depict an if-else block? And it's actually very, very similar to what you've seen in most other languages. Some languages do not have a construct called an unless, but in this, just like Ruby, you have something called unless. So it takes exactly like the same. So if, and then the condition, and do an end, which is a block, and inside the block you tell it what to do, right? Exactly like Ruby and possibly other languages also. Same case with this thing also. So the next thing that I wanted to look at was, in most languages you can obviously do an if, else if, else if, else if, and have a big ladder. But we typically want to avoid that. Why do we want to avoid that kind of a, why do you want to avoid that kind of multiple if-else conditions? Anybody? No man, you've been answering lots. Anybody else? Nobody wants to answer that. Okay. That's yes. And also it has a performance fit also. So each still the condition that is valid, right? The compiler or interpreter or whatever has to go and evaluate every condition in sequence, right? So if you have 20 odd conditions and 15 condition is what is valid in your scenario, based on the variables you're using, the first 14 will still be evaluated, right? So that is the biggest advantage of in most languages why you have a switch case, case when those kind of constructs in the first place. Because the compiler, based on in this case regular expression pattern matching, but in other cases different other mechanisms, it can very quickly identify and go to the block that needs to be evaluated. Okay. So in the case of Elixir, this is how a case statement is written, where you have the case and then uh, what you want to uh, evaluate on, and then the resulting pattern matched expression for that value. Okay. So I'll explain how this works in Elixir with this, because this is the first time I'm introducing the word of pattern matched uh, code execution. And that's very, very key in Elixir as a language. That's what sets it apart from most of the other languages, right? So you can see that there's a tuple which has the values of 1, 2, 3, right? The first construct here is 4, 5, 6, and so will it match? Are they equal? They cannot, right? So it will automatically bypass and go to the next one where it is a similar tuple of 1, x, 3. And so what it matches is on 1 and 3, and so it knows, the compiler knows that it has to go into this clause. So what gets printed is this clause is matched and bind x to the value of 2. So one thing that if I type in this, what does that mean? What does that mean? In most languages, it is an assignment operator. Equal to is an assignment operator. But in Elixir, all it means is, does A match or bind, in this case it's called binding, it binds to the value of 1. I can rebind the same variable to another value. It's perfectly alright. But if I do this, that doesn't work with integers. But the caret symbol is what we use to say it is now a constant. It should not be rebound anymore. Okay, that's how we define constants in the language. So what that does is you can define variables. Typically in say web programming, you have some request, you have a router controller, you have a params hash coming in, and you want those hash values and maybe nested values and stuff. All of that you want bound to your variables in the controller context, method context, right? That happens by default in Elixir. So this power of the language is very evident when you start doing those kind of programming. Okay. Any questions till now? No questions. Okay. I've not yet closed Phoenix, and I have 3 minutes to go further, or what should we do? Do a little bit more. 10, 15 minutes. Okay, so you're all okay with that, right? For the 10, 15 minutes of this? Or is it too boring? Please tell me, I'll stop. Okay. Anyway, one of the things is that I'm not very good at speaking. This is just my second or third attempt. So please bear with me on that. Okay. So what we'll do is we'll come back to some more features of the language. Then we'll go into what you might end up using in a real world. Okay. So So one of the things is, as I said, it's compiled as opposed to being interpreted. Even though so this one of the cool features that I noticed is that even though so in the Ruby world and all you have a REPL, what other language gives you a REPL? First of all, anybody else? Anybody done say Ruby, Python, Haskell? Yeah. So these are the languages that I know of which give you the REPL, right? Of which of these are interpreted versus which of these are compiled? Yeah. So this is one of those languages where it's actually compiled, but it gives you a REPL so that you can go and work play around with those same things. And of course, it's functional, so all the functions are also first class citizens. So what we'll see here, actually, is it too small? Or can you all see? Sorry. Stop. I think it's unused. Okay, anyway, sorry about that. So what I've done, sorry, no, it doesn't work. So what I've done is I've defined a function called sum underscore fun, okay, which takes a list, a variable called list, and I've also done something called overloading, but overloading in how we do it in Elixir terms. So in typical say Java or .NET, when you do overloading, what do you have to remember to do? What are the constraints of overload, method overload? Yeah, maybe different, but the return type has to be the same, right? So method name and return type have to be the same. The whether it's private or protected and all that also has to be the same. But the number of variables can be different. Some languages also allow you to say, for example, you can do the same thing in Ruby, but you typically do that with optional parameters. You don't really do method overload, right? That's how you can do method overloading with optional parameters. In Elixir though, right, what I mentioned back some time ago called pattern matching, you can say that the method is applicable only on a condition based on that pattern match. Okay. So, sorry again, for those who can see the first one here on the top left, what this means is that the sum fun, which takes with an array of one, which takes a argument called list, is only applicable when this condition is true. Means when it's a is list of that list variable returns true, then only go into this particular method. Otherwise, it will actually the compiler will try to go to a different method definition itself. Okay. So if I were to do this sum fun list when is list, then it will go here. If it does sum fun of r, then it will go to into this right on the right hand side. And the third one is when it's an integer, then it will go into this one. Right. So let's go and play around with these. Okay. I'll just call it bits for now. And again, just for brevity, I'm just using a single character name, but variable names should not be single characters. Is list of any two puts list. Oh, good. I think I messed up my thing. Anyway, don't think I can show that. But take my word for it. When that some fun is invoked, or which in my case was invoked with any variable. Then it will pattern match on whether it's an integer. If it's an integer, we go into the lower left, method. And there again, it's going to invoke another method called SumFun. And this time, it's going to bind a variable called item. Item, as you can see, is defined inside of an array. So do you know the word splatting in Ruby, right? Explode, right? Barags in Java. So we'll explode that array or list and assign that variable value into item and then invoke some fun in this case. That's how you have to read this code. Okay? And at that time, when it reinvokes some fun, because it's an integer, it's going to go into this one. It's going to go into some fun arg. So finally, it will say this way.
So it's like calling the values of that list. I mean, it's like recursive calling.
Yes, it's like recursive calling. Okay, so this is the last piece. I'm going to stop here after this because after this we'll go into Phoenix, or I can show you one more about. Sorry. not that Phoenix. So after this I'll show you one more slide which is related to all the tool sets that you have in the language at the language level. So you can all see this code and it should actually, does it look good? It's kind of understandable, right? Because you've probably done a lot of method calls and then daisy chain methods and all of that stuff, right? But how does this look? How does that one look? Does that look better? It's much more readable, right? That's because of, at the language level, there's something called the pipe operator. What that does, so how many of you have done Unix programming? Bash or shell scripting as opposed to Windows Bash. So you know the pipe operator, right? So the pipe operator in the Unix world takes whatever's on the left, evaluates that or runs that command, and pipes it to the next command as the first argument. You can have other arguments, but the first argument is that. Exactly the same thing in Elixir. So what that allows us to do, if I were to describe the top portion, the first thing, the innermost function is going to do is this find user by token, passing in something called user token, some variable, and take the value of that, this first guy, and then have another second argument which is a string which is /messages /unread. Pass that whole thing into a method called fetch. The result of that is then put into parse JSON to messages. And after that, the result of that is taken into enum.each as the first argument, with the second argument which has this crazy thing. Okay? Right? So that's how you have to read that. That's how it's going to be compiled and done. But in Erlang, you take the same thing. You can, of course, write it that way also. You typically don't want to write it because of the readability aspect of it. You take it and put it in this style, where you say user token, pipe that argument as the first argument, pipe the value of that as the first argument into something called find user by token. Take the result of that, pipe it into fetch. But here you can see fetch which takes only one argument. But when you use a pipe operator in Elixir, the language, it will automatically put whatever came before the pipe as the first argument, and after that only append all the others. Okay, so that is the only thing that you'll have to, that might not strike your mind immediately when you see this, but that's a very small and important concept you can very easily learn. It will become routine by default afterwards. So you can see how I'm understanding the code, very easily. Another biggest feature of this is every method call every method that gets invoked is functional in its context. Means that the value that's passed in will never change. There's no threading issues at all to worry about. Got it? So every method is intrinsically like that. Okay. So last couple of slides. How many of you can understand this? This is basically typically what a monolithic application does. It has many different pieces, but all the pieces are combined in one process, one running system, right? All these dots, the user registration, instances or not instances per se, but worker threads, if you will. User transactions, the email process, all of those reside within the same process. So if one of them bombs, throws an exception, and you don't actually catch it, then your whole system is going down. Right? This is the traditional monolithic style of architecture. But with Elixir and Erlang, so there's something called OTP. If you Erlang, OTP, Elixir, OTP, every module, deployable module in Erlang or in Elixir is called an OTP application, right? There are scripts which are like bash shell scripts or whatever, but what you run in a VM is typically an OTP application. An application by default has something like a main, if you know, uh, and it has something like a running process. And remember, I said something about supervisors, which was another feature of the language, right? So Elixir also gives that feature of the supervisor where you can go and monitor the worker processes themselves. You can just say when you're deploying an OTP application, OTP by the way stands for Online Telephony Protocol because it came from the Erlang world, right? They were more interested in telephony stuff. So OTP stands for Online Telephony Protocol. And what they wanted to do was something that is always online, as in there's no downtime per se. So what they developed as a feature of the language itself is something called supervisors, where you can write an application, you can write its supervisor module, and the supervisor will always make sure that there is at least one worker to satisfy or to process your request, whatever the request. It's not HTTP request, whatever incoming request is, it will go and satisfy that. There is always a worker process to handle that. And any worker process that fails in between, the last known good state of that is used to restart a new worker process. That's the key to hot reloading. The last known good state of an in progress worker process is used to spawn a new worker process, and it continues from that same point onwards. Okay. So what that does is in this case, in this picture that I'm depicting, you can actually have multiple such small OTP instances, application instances, one for like say user registration, one for user transaction, one for email process. And when I say one, it's actually a group. You can say that this is my template for the worker process, and I want 3 of these. You can you would have worked with connection tools, right? Whether it's Java or .NET or whatever, databases connection tools, you will work with them, right? Typically in production, you will say, I will want a minimum of 20 DB connections and a max of say 75, right? So that means that when your application is loaded, even if there are no requests, you're going to take 20 connections, put it in a pool, and have them managed, right? So the same concept, but at a thread or a process level. And this is provided by the language itself. There's no library per se that's given. There's no third party or open source or anything else. It's the language which is giving this feedback. I'll show you an example of that. So this is what you might end up doing for what I was describing. You might end up writing this in say Java or .NET. They look very similar. So you'll have like a run method. It will have a while loop. You'll have to put that whole thing within a try catch block. And if some kind of exception occurs, you want some listener somewhere, some other module to be listening to that, right? And when that gets triggered, then you have to have some other process which the listener triggers to say, okay, restart this process, this worker, right? But the same thing, because of the language construct that I was describing, you can have on the left, this is how you define a worker. Nothing, all you need to do is you need to expose a public method. You need to expose a public method and do your stuff. Your domain, business domain functionality, whatever you need to do, the core of it, you can do it here. There is a separate supervisor, and the only thing here is that you have to use a module called supervisor, which by which then the VM knows that this particular module has some special characteristics, and you can say worker, my worker, blah blah blah. That's all. So that way you know that this will, if I were to deploy an OTP application with this, these two modules, then I'll know that I'll always have at least one instance of my worker always running. Even if it crashes, it will start automatically. I don't need to worry about having another queue or a listener process or any other, or maybe a cron job starting it up or anything like that. So this is one of our colleagues found this, and this shows exactly like what happens in inside the VM. So everything is running. Okay, this picture, I guess, I don't know if it was real or not, but it's supposed to depict somebody going at like 60 miles an hour, 60 kilometers an hour, and time of puncture happens. They want to change the flag while the race is going on, I guess. But this is what happens inside the VM. So I have my old version of the code running and servicing requests, and I deploy the new version, and the old one, the last animation. So the old, all the jobs that the workers are doing in the my module version 1 get slowly throttled. All new versions only come into version 2, and the old one, when the last job dies, then it's removed from the VM. Right? All that happens in memory. You don't need to worry about it. Okay, so let's stop here. I think we are at 10 is that. Anybody have any questions? No.
In the point of view process, if there is some exception, then it will spawn only it will spawn a new workload, right? Suppose, what about the thing that was happening, that was causing an exception, right? What about that?
That's what I said, right? So the last known good state of that worker process, there is something like a registry. So the last known snapshot good state is taken, and then when the new worker is instantiated, so there's a concept of templates and data. Think of it like that. So the template instance of the template is created, the data is applied, which is that snapshot, which is the last known good state, and then it kicks off from there.
So the request whichever caused that exception will not execute the instance. That's what it said. So the next process it will execute.
So this is at a language level. So when we say request, it's any thread request or interrupt signal or something like that. Right? It's not like your typical web request. But yeah. So there are actually many sites where they are posting such things. What the best one that I've seen is they converted a Ruby on Rails application which needed like 25 servers and was doing some number of thousands, X thousand, 2,000, 5,000, 10,000 requests or something. They moved all of that into a single instance with running a Phoenix application, and it did not go more than 30% CPU usage. So 25x of servers got moved into 1x of server, and of that only 30% usage was done. Just because of that. Concurrency, garbage collection, all of those things. With? No, I don't. Sorry. I've done Golang, but I don't have any comparison. Sorry? No, you'll have other concepts. You can catch the exception, you can log it, you can do all of that. You can do your whatever you need to do at a business or domain context level and rethrow the exception such that the supervisor knows that it has to spawn a new process. Only thing is the difference between this and this is this guy, the listener notify exception. That piece you do not need. The exception handling the same as other languages. You do have all that. Anything else? Okay. The problem is that we have actually only covered a very small part of the language. Just like Ruby was actually started, the language was started back in like 98, for those who don't know. But it came into prominence only in the late 2000s, right? In fact, when ThoughtWorks did the first project for Ruby on Rails, the first client, we actually did it for free for them. And then only it became a paid gig for us. Because it was so unknown at that time, nobody wanted to even at an company, level, they didn't want to invest in technology that was so unheard of. But at the same level, same similar style, the Ruby as a language came into prominence only because of the web framework. Predominantly Rails, but also something called Merge, right? Similarly, in Elixir, the language provides a lot of features, but it's only useful for a small context in our current world scenario, unless you're doing, say, hardcore, say, embedded programming or something that runs on ARM chips or something like that. But predominantly, most of us do web-based or e-commerce, B2B, B2C kind of applications, right? So in that context, the Phoenix web framework will bring out much more the power of the language. Unfortunately, we'll do that the next time.
We can do a follow.
Okay. Cool. Thank you.
Vijay is going to be around.